Hello and welcome to the third video in our series on circles and circle theorems. I'm Mr. Chowdhury and today we're going to be looking at area and circumference of circles. So before we do anything, I suggest you go watch our first two videos to help you out. One of our videos is specifically on labeling circles. What I've done here is giving you a diagram, just a reminder of each part of a circle. The main ones we're going to be looking at is circumference, radius and diameter. The rest of them are useful to know, but they won't be coming up in this lesson. So the main ones we're going to be looking at is radius, circumference and diameter. Now let's begin. The circumference. What is the circumference? To help you understand what the circumference is and how we work it out, what we're going to do is watch this animation. And here we are. Through the magic of some post-production, we are in our animation. So what we have here is a circle with circumference in red and the diameter in blue. We can make the circle bigger or smaller. We're just going to leave it where it is. Now, just a reminder, the circumference is the distance around the outside of the circle. The outside of the circle, the distance around it is the circumference. So what we're going to do is we are going to unravel the circumference of the circle. So there we go, we've unraveled it and we get a measurement. We are then going to take the diameter and just place it there. Now we have a new action now we can do. We can measure the circumference in terms of diameter. So right now we can see the diameter is about 1.5 centimeters and we can see how many diameters fit in our circumference. We can see how many diameters fit in our circumference. So if I press the measure in diameters, well, we can see we've got 1 diameter, 2 diameter, 3 and a bit diameters is what our circumference is. 3 and a bit diameters is what our circumference is. And we can see this regardless of how big the circle is. So let's make the circle smaller. Right, we made the circle smaller. Once again, look, the diameter thing is still in terms of diameter, so the diameter is still the correct measurement. We are going to unravel it and we still get 3 and a bit. Okay, so here we are back in our presentation. So from the animation, the key thing we should have taken away was this, that if we take the circumference is 3 and a bit times the diameter, and that does not matter how big the circle is. The circumference will always be 3 and a bit times the diameter. Now you may be wondering, why are you saying 3 and a bit, sir? There must be an exact value for this. There must be. Well, the truth is there isn't an exact value, but there is a value for it, and that value we call pi. And this is roughly what pi is. I've obviously not given you all of the digits of pi. There are people in the Guinness World Book of Records who have memorized thousands of digits of pi, but this is roughly what pi is. And if you were to look online, most people will recognize pi, the Greek symbol pi, as the value 3.14 is what you would hear most likely. So if you went and searched for it yourself, you'd hear it referred to as 3.14. That's just what we usually round it to. That's what mathematicians use when we're trying to estimate. When we're trying to use pi, and we need a bit of an estimation because we cannot use the full number of pi because it's transcendental and it goes on forever. So how do we use this to find the circumference? Well, we know the circumference is 3 lots of the diameter, 3 and a bit lots of the diameter. So it's pi lots of the diameter. And if I was going to write that, I'd write it as pi times d, pi times the diameter. Now you may be asking yourself, well, what if I don't have the diameter? So instead, it's going to be pi times 2 lots of the radius, because we know the radius is 2 lots of the diameter. Now here on my circle, I'm now going to draw in a diameter in green and a radius in purple. So just to give you a reminder of what the diameter and the radius is. So this is the two forms of finding the circumference. We could just do pi times the diameter if we wanted. If we had the diameter, we could just do pi times the diameter, or we could do pi times 2 lots of the radius, and that's how we would find the circumference of a circle. So now that we've looked at the circumference, we can now look at the area. So the area of the circle is the space that circle takes up. Once again, just to remind you, this is going to be coming back to help us out. So pi is an integral part of working with circles. So now let's go and look at our animation. Okay, so let's have a look at this animation and what happens to this circle. So what's happened here is we've created a triangle where the base of this triangle is the circumference of the circle. We've then worked through to work out how we would find the area of this triangle. So if you look, we know the area of a triangle is a half base times height, and because our base is the circumference and our height is the radius, we can substitute those values in, and then we know it's 2 lots of pi lots of radius to work out the circumference like we talked about previously, but then it's multiplied by the radius, so then 2 times a half gives us 1, so that cancels out, so then it's just pi times radius squared. Okay, so before we move on, just to recap what we just saw in that animation, we have our radius. That's really important. It creates a triangle if we unwrap this circle into like a shell, and this is how we get to the area of a circle formula, which is pi r squared. Okay, so now moving on, we're going to be looking at something a little bit more specific. So these are not quite circles, but it's really important that you know and understand how to work with circles, finding the area and circumference to answer these types of questions. So we're going to go through all three, and hopefully this will help you understand it a little bit further. So we're looking at the first one. This is a strange little shape. Looks like a pill. So how would we work out the area of this shape? Well, we can split this shape into 2 shapes. We can have our 2 semicircles, which create a full circle, and a square. So to work out the area of this shape, we would do the square and the circle and add them together. So we can do that very simply, and that's why it's important to know how to work out the area and circumference. Okay, what if we wanted to find the perimeter of this shape? Well, what we need to do is we need to find out the perimeters of these semicircles, so work out just these 2 bits of the semicircle, and because we've got 2 parts of it, it would be 1 circle, and then the 2 missing lengths on the sides. So you get the 2 sides plus the circumference of that circle. Okay, so let's have a look at the next question. So we have this weird shape, and what's this shape made up of? Well, this shape is made up of a triangle and then 2 semicircles, so that's a triangle plus a circle. And we would just find out the area of this triangle, the area of this circle, and add them together. As you can see, again, it's really important we understand how to work out the area of a circle so we can combine it with the area of that triangle. Okay, what about the perimeter of this shape? It's the same process again. We find out the perimeters of these 2 semicircles, the outside parts of these 2 semicircles, which would be the circumference of 1 circle, and this length here. So then you have the length plus the circle to work it out. And lastly, this shape here where we have a circle with a bit missing, well, that's made up of a circle and then this square, and you end up with the circle minus the square. So hopefully that's been helpful and you've been able to understand area and circumference of circles a bit better. If you're feeling super confident, go and watch Mr. Amison's videos. If you need to watch this video again just to help you out, that's perfectly fine, do that. If you want to go and try some really difficult questions, Dr. Frost and Corbett Maths is where to go. Go off, be productive, and I'll see you in the next video.